Good afternoon. Today we are glad to have Nicholas, the founder of Harvey Rock Physics, and also the creator of the software LogScope, and he's going to share with us about how to extracting and uploading data from the Open Subsurface Data Universe (OSDU), which is a very popular topic among the geoscience community. And Nicholas worked in the oil and gas and mining industry for more than 30 years. And he had a degree in applied geology from Curtin University in 1985. He has continuously worked in the oil and gas and mining industry since 1984. In mid-2011, he started Harvey Rock Physics with James Horneveld. His primary focus is borehole image petrophysical techniques, and also testing LogScope and building new workflows, and talking to clients about the application of Harvey Rock Physics service and software. All right, so Nicholas, now you have the floor. Thank you.
Thanks. I hope everybody can see the presentation. And I was asked to talk about what we've been doing with the Open Subsurface Data Universe. So this presentation basically presents a workflow, for some of the things that we were doing for extracting and uploading data to the Open Subsurface Data Universe. So I'll just start on this. In summary, the OSDU is a cloud-based storage system. It has schemas that are very well known and are publicly accessible, and it can store large amounts of information. What we'll be doing in this presentation is just presenting a workflow that shows you how you can extract data from the OSDU, perform a multi-well analysis, and upload the results. The presentation will be a mix of static PowerPoint slides and videos that I'll walk through some of them, and one in particular that actually goes through the Petrophysical workflow. I've pre-recorded myself, so just to make things easier and quicker for people to see. When I sort of go through the advantages of the OSDU, the first one is data integration. The OSDU facilitates the seamless integration of wireline log data, and that's essentially what we'll show when we upload the data. Is you can upload the data in file formats that are known, which is LAS, DLIS, and LES. So this means the data is going to end up in the OSDU in standardized formats. And this allows easy shareability across applications and domains because they're well-known standards in the industry. And this leads to enhanced accessibility. So once the data is up there in those formats, it's very easy to retrieve it in whatever application you're using for implementation in workflows and for people to see it. And obviously this results in improved collaboration, because once the data is stored in a unified platform in formats that are well known, it's very easy for people to extract and use. And obviously this is going to lead to better decision making and efficiency. And finally, because of the fact that it is in publicly available formats and so on, cloud native capabilities, once they access the OSDU, are able to sort of push and pull the data that's raw, and also the results that are produced from conventional petrophysical interpretation techniques that are uploaded to the OSDU. I just want to give a shout out to WePro, who helped us in putting this together. They are data integrators and workflow and a workflow company. I also want to give credit to both Microsoft and a group called 47 Lining, who, as we were developing OSDU, we were given access to both their OSDU platforms in order to develop it. And I'm using a combination of all platforms in putting together this this workflow. So the actual workflow itself is I'm going to show the initial ingestion into the OSDU. We're going to show a little vignette video of uploading from LAS, DLIS, and LIS, and then uploading directly from our software, which is LogScope. I'm then going to show you how we download the data for specific wells from the OSDU for the petrophysical evaluation. I'm choosing about 15 wells to show you how that's done. We'll then do a petrophysical evaluation, and we'll use a multi-well petrophysical evaluation that uses a predefined model, silty shaly sand model in this case. And the parameters are from reference wells that are spatially located in our software. And I'll explain a little bit more about what I mean by that later in the presentation. And finally, I'll present a cross-section of the results, and then I'll show how the data can be uploaded directly back to the OSDU, and we'll validate that in a map view from our interface with the OSDU system. Some of the assumptions that I'm making here is the data I'm using is from a project we did quite a while ago, where we edited the data, top and tailed it, removed the casing effects and the tool pickup effects. We did SP drift correction on the data, and we made sure that the header information and the run information for each of the wells was complete for all the wells. There's over 400 wells that were in the data set that we used, and it comes from the Cooper-Eromanga Basin in Australia. So when I talk about header information, I'll just switch on my laser pointer here. We are talking about information such as the company that commissioned the well to be logged, its name, the latitude, longitude, and the elevation, and sort of the other information such as that. The elevation and the latitude and longitude are what give the spatial coordinates for us, at least in the OSDU. We then load in all the run information as well. So we've got the top and the bottom depth. And then if I move over here, we load in the fluid properties, density, and all the resistivity parameters, and the bottom hole temperature. And these are important for the temperature gradient that you use in the well, and also for understanding the resistivity and how it reacts within the particular formation. Those of you who may have worked in the Cooper-Eromanga would understand that these are particularly important, as the wells have there is variable water salinity through the sequence, and it's not all that saline, having salinities that range from fresh to 30,000 ppm, and in some cases more. So the first thing I'm going to talk about, as I said, is the initial ingestion, and I'll run a full screen video and walk you through that. And the first thing we'll do is the upload from LAS, DLIS, and LIS. So this is the first video, and as we start on this, this is the last file upload. So basically, when we open up the OSDU, we have an O button down here, and we open up the OSDU. We choose upload, and it gives us the creation properties. And then we add from the file, and we choose our last files like so. We can choose multiple files. And then we hit open, and it gives us a list of the files that it says it's going to load. And then we hit OK, and it uploads the data. And then in the map view, we can go and we can search using polygons or a standard list search. I'm going to use polygon. And you draw a circle around where you want to search. And I'm going to put in for a well named sturt. I can put in log names and so on. And I have the wells listed here. And then I can expand and blow that up. And you can see that I've got all the wells loaded into the OSDU. And that's LAS, DLIS, list upload. It will load the information like that. It extracts the information from the header and populates the metadata inside the OSDU at the same time, so you can actually see the wells located. If you have formation tops and so on, those can be uploaded as well. Typically, most people like us, when they're doing a petrophysical evaluation, will need to do some work on editing the data, filling in the data, as we said, populating, depth matching, top and tailing, editing the sonic, merging the data together, and doing the core graphical image data. So essentially, you will import the data into your software package. You'll do all this editing, and then you can export the data to the OSDU with either LAS or DLIS, like so. And to give you an idea of how that's done, I'm just going to show you the direct project upload to the OSDU in this next slide. So I'll just start the video and I'll walk you through this. We're going to upload to Azure this time. And I've got, as I said, I've got over 400 wells listed here. And the first thing is the OSDU. And you have a standard set of credentials that you have to load in. One of the key ones is the client secret, which I've blocked out here. So basically all that information you put in, and in our software, we load it as a list of parameters, and then you just hit open and you go there. And then the first thing we do is we hit upload. And again, we've got the same creation properties. And you fill those in. And the legal tags we want to change. We're going to add a different legal tag. Legal tags are essential for uploading data to the OSDU. You have to fill these in. So the first thing I do is I'm going to give this a different legal tag and call it Cupramonga. I'm then going to give it a description of the Cupramonga basin. The country of origin is obviously Australia, which is predefined. There's no contract. I'm going to give it an expiry date. And then the next thing I'll do is I'll give it the originator, which is obviously me. We can set up the data type and the legal tags. This is one of these. We're going to choose first party data just for the heck of it. And then you have security information, whether it's confidential, private, or public, and then whether or not there's any personal data in there. And then the final is the export classification, and there's no license required here. And then we just press on OK, and it'll go away and it'll create those legal tags. And in our software, we can choose multiple legal tags, so we're just going to choose one at this point. And then we've got the creation properties like so, and then we're going to add the projects. And because I've selected them in my software, it adds them all in and it gives me a complete list. Obviously, the upload that I'm showing here takes a little longer than what I'm displaying here, but I've sped it up so that you can actually see the uploading. At the end of that, we get a nice report telling us what's been uploaded, what hasn't, and so on. And again, the same thing is once we're in the interface, we want to see where the wells are. And again, I like doing things spatially, so I draw a polygon around there, and it shows me all the wells that I've loaded in that particular area. And I'm just showing the wells like so, and I'll just blow that up, and you can see the wells there. So the next thing is downloading the specific wells to actually perform our petrophysical evaluation. Now, those first two steps may have been done months, years from the time that you need to do the petrophysical evaluation. Just as a side note, when we started playing with the OSDU about 3 years ago, I really liked it because you could upload an enormous amount of information. You could have it presented to you spatially. You could see what you wanted to grab, and you could then just go in and you could just highlight what you needed. And for me, when I was finishing the project, I thought, this is an ideal interface for presenting the information to people who want to examine the work that we've done and want to use the data for other purposes, and use our results for other purposes. So I'm going to download specific wells from the OSDU now. And again, this is a video. So basically, whoops, I'll just click on the video to start that. Maybe here we go. Now I choose the polygon again, and I'm going to select an area, and this is downloading for an interpretation. This is where I want to do an interpretation. And I choose all the wells, and I want to choose my wells in this particular area here. So I'm just going to blow this up, and then I'm just going to move it so that you can actually see the wells. I've just expanded the area here, and there's about 15 wells here. So I just draw a polygon around the wells that I want to download, and then I just press the download. And those wells are downloaded into the software, and then just to see the information that I have in the software that I'm using, I'm just going to draw a cross section, and I've got the cross section set up, and here I've got a triple combo, and in this I've also put in all the formation tops as well, and you can see the wells that we've got in the section that we're using for the interpretation. So that's downloading the data. So I have the data ready to do my petrophysical evaluation. And these I'm going to, from my perspective, get into the meat of what I'm doing. Is I want to do a multi-well petrophysical evaluation. I want to do an evaluation on all those wells, and I want to present those results in a cross section so I can actually see what I've done. And then I'm going to upload that information. So I'm going to move to the next slide. And this is a static slide. And the software that we're using when we use our multi-well evaluation tool gives us a vignette of the wells, and the diamonds are the wells that have all the petrophysical properties that I've got in. And then I've got the diamonds are the wells that don't have any petrophysical properties. and the lines indicate which well it's going to get its petrophysical properties from, because I've got multiple wells with multiple parameter sets in, and it's pulling that information from the diamond annotated wells. Our software is a crossplot based approach. It's a crossplot based deterministic approach. So I have a bunch of crossplots, and I can move the points on this, and I can see all the data from all the wells plotted on top of each other in the crossplot interpretation. For each of the intervals that I interpret, and for the purposes of this, I'm just going to use one interval, which is the Burkhead Formation, a very interesting sand shell interval within the Cooper Omega. And on the right-hand side of this, I have a plot that gives me a vignette of the CPI interpretation, showing me what the interpretation looks like for this particular interval. And then down the bottom here, if any normalization of the data is required, I can see how the curves sort of look across all the wells in a histogram. I've done the gamma ray, but I can actually look at any well that I like. And as I move the points on this cross plot, this little box on the bottom left will get populated, and you'll see that in the video when we get to that. As I said, it's a crossplot based approach. We have all the crossplots in the software. They're all cross-linked, so if I move the points on one, they change on the other plots, and it basically shows everything that's going on. And I can walk through all these crossplots in a multi-well approach. So now I'm going to play this, and it's going to play as a video, and there's a soundtrack laid down because there's an awful lot of information. From the cross section, we use the LAM to access the log analysis multi. We then use the OSDU project to go into the specific project. And then we show the wells, and they are shown spatially with the key wells indicated. And then we can go and we can see them as a list with the wells, the key wells with D plus P, and the target wells as just D. We then have the ability to choose whatever processes we want. We can choose the input curves and make sure that they're consistent across all the wells. And then we can go to the parameter store and select and save those. We can use the options to view individual or single wells, which I'm showing you here. And then we have the ability to see the formations or the zones, zone by zone. I'm just going to process one zone for the example of doing this. And then we have the cross plots, and the cross plots are shown here. We start with the neutron density cross plot, and we can work our way through the neutron sonic and the sonic density cross plot, as well as other cross plots such as the M factor, N factor. We can choose to see well-specific parameters by select well. We have the ability to select and highlight particular intervals to see what's exactly happening within a particular zone and where the points fall for a specific well or multiple wells. Finally, in the environment that I'm working in, I also have the ability to lock the scaling of the crossplots, because the scaling of the crossplots can move freely. Or I'll put multiple crossplots. And as we scroll through the crossplots, we've got them here, and we just work our way through them. And as you can see, we've got the full complement of crossplots that are available for interpretation purposes. We can also look at normalization of the curve. So in the bottom window I've got here is I've got the gamma ray, which I select, and I can normalize it if I wish. I can then move my points about on the cross plot. I can see my normalizations, and then I just go into process. I'm going to do all the wells. I'm going to do the current zone. I could do all the zones, and I just hit OK to run it. And it runs through the process and produces the results. So once we've completed the analysis, we will want to look at it. So we can look at it individually on each well one by one. But I'm going to go back to the cross section, and I'm just going to look at the wells in one cross section. So we hit the back button and it takes us back to the cross section view, which is here, and the wells are filled in. And then we go to the configure, and we're just going to change the plot, the zone that we're looking at, to being the Burkhead. And I'm going to you put one zone above and one zone below, so we've got some context with the zone that we've calculated, or the zone that we've done the petrophysical evaluation on. And then I just display that information. And I'm using a plot view that gives me the full CPI plot, or calculated petrophysical interpretation plot. And I just do that, and it displays the information. We can work our way through the cross plot, and we can see it side by side. But after we've done this, we want to see the entire interval, so we can do that next. So what we do is we go up and we select zoom, and we use the depth scale to fit, and this allows us to see all the wells at the same time. And we've got the Adori above, and we've got the Hutton below, but the zone of interest is the Burkhead, which has multiple different RWs and zones that have hydrocarbon in and zones that don't have hydrocarbon in. So that's basically doing the petrophysical evaluation from the cross. And the other thing that I didn't show there is when you finish the evaluation, you can also produce a hydrocarbon volume report from the multiple wells within that, and show all the things up to and including average permeability and flow capacity for each of the intervals. The final thing is once you've got that information and you're happy with it, you want to upload that information back to the OSDU. So we basically use the same approach as we did with the initial ingestion, and we just do a data upload. But this time our wells have the petrophysical information in it. So I'll just run this video and walk you through it. So here I've got all the wells here. I've got them in a list. I'm going to change to a map view so I can see all my wells here. So I just draw around them and highlight them, and they're highlighted in yellow. I then go to the OSDU, and I'm going to choose the AWS OSDU to upload, and it takes me in there. And then I just go upload, and it comes back, and I choose the legal tag that I want to use. This time it's the OSDU Cuperamanga legal tag, and all the other parameters are the same. I add the projects, and I can say the selected projects, and it's going to upload all that information, including all the formation tops and so on, that I've worked so hard to put in there from my petrophysical evaluation. And once they're in there, we're going to circle the polygon. We're going to type in the well name just to make sure that that information's up there. And then we've got the data there, and again we can go and look at all the wells, and there we have the data in the OSDU. And as I said, this is really, really nice, because then anybody else who has access to this particular OSDU database can go in and just pull that information down and look at it, and see that information. So in summary, basically all I did was show you initial ingestion, show you how you can download directly from the OSDU, perform a petrophysical evaluation in your software tool once you get that information downloaded, produce a cross-section of the results, and then I guess key to this is upload that information back to the OSDU. As I said, the things that I really like about the OSDU is that it's nice. It's a nice flexible storage environment. Once you connect to it, you can put a lot of information there, and you can have your colleagues access the information directly and without much trouble. As I say, it's an easy place to make interpretation results readily accessible. You can look at the data spatially, provided your interface allows you to look at it spatially. But you can sort of review the data not just from one environment. Like, for example, the OSDU databases that we worked in had the TNO data in, and other example data. So in the one database, you can actually see the spatial arrangement of all the information, and you can basically look at it very easily all over. And our software, LogScope, we've designed it so that we can upload and download directly to the OSDU. And that's it. That's all I have for a presentation. I'm open to any questions that anybody may have.
All right, thanks, Nicholas. There's any questions from the audience? Can type to the question, the chat. Yeah. So I have a question. So you talk about the well log data. So how about like the other type of data, like core and image data?
Yes, you can upload core, and you can upload both discrete core data, which is like your scale data, which is standard conventional analysis data or special core analysis data, and the conventional core analysis data such as porosity, permeability from core. But you can also upload core photos. We experimented with uploading that, but the one thing we found was that for core images and so on, you know, our understanding is that people are still discussing the schemas that are going to be used for that. But we kind of cheated when we uploaded that and created our own schema to do that. And yes, we can upload both those sets of data in, and I have a video that shows us doing that in a much longer video of what we do in the OSDU, which I can provide a link to. So yes, with borehole image data, we ran out of we basically ran out of time. But yes, you can upload and download directly from the OSDU, the DLIST files, and do your image interpretation, and then upload that information back to the OSDU. Yes, we can do that. It's just following this approach, but instead of petrophysical evaluation, you're doing borehole image interpretation, or whatever you're doing with the borehole image in here. Hopefully that answers your question on that.
Thank you.
One question, why not do the interpretation in the cloud? Is that possible?
I'll answer it in two ways. LogScope can work in the Delphi environment, which is a cloud-based environment system. We've been talking to SLB about that, but it's not available yet. We're sort of looking for somebody to test it out. But we designed LogScope to work regardless of where LogScope is, the environment that's inhabiting, be it a cloud-based virtual machine, or be it your local machine, and so that it could connect directly. In terms of actually being able to do cloud-based interpretation, you essentially need to be able to access, you need to be able to do this part of the process in your software, obviously, and most cloud-based software can do that, but your cloud-based software needs to be able to download from the OSDU and upload the results directly back to the OSDU. So those are kind of the two steps. In our environment, you could download the data into our software using this, export as a CSV file, put that in whatever you're doing, bring it back into LogScope, and then upload back to the OSDU. So you could do it that way. Or again, you could access the APIs directly from your cloud-based software and download and upload to it. We sort of, the workflow is built around how we operate. But for anybody who's got artificial intelligence stuff, that's the approach that they take. Our software does also connect to WITSML servers and stuff like that. So we can actually download from the WITSML, perform evaluation or massage the data, and then you can upload directly back to the OSDU, which is kind of similar to what you're saying. Basically, where we've got the perform petrophysical evaluation and cross-section of results, you just stick in there cloud-based processing. Hopefully that answers your question. Probably more information that you wanted.
No, that's fine. Very good. I'm thinking by analogy to what I do in GitHub. I have code spaces and I start a virtual machine there. I can do a lot of stuff there. And then when I'm finished, I log off, and that memory is free to another person to use. So you could imagine that a company who wants to do an interpretation on the data they have there, they could maybe start a virtual machine, starting up some applications on that virtual machine, interact with the data that was on OSDU and do it completely in the cloud. But maybe that is for the future, maybe.
Yeah, I think we developed the first step, which is like, okay, let's access the data directly and let's push the data back directly. And then the intervening steps, which is whatever you want to do. We provided the tools in our software to allow us to export CSV and so on. But we can also connect directly to APIs that are that access cloud-based systems, and we are talking to several companies about that, which, you know, down the track, you could use LogScope to pull that data down from the OSDU, push it to their software, you get your results back, and then you upload, which is essentially what you're doing with the GitHub environment. Except hopefully we've developed an interface that's a little bit more friendly than having to write your own code to extract the information and push the information back. You know, it's kind of...
So LogScope is pretty flexible.
Yeah. Yes.
Okay. Thank you.
So I see there are a couple of more questions in the chat. And Nicholas, can you see these questions?
I will as soon as I stop the presentation and get my...
Okay, so I can read one of the questions for you. So are you aware of any limitations at this time to downloading large amounts of data, especially from images, image logs, and array data from OSDU?
Well, I can only speak in the context of the tool that we've developed ourselves. And our tool, we've worked with the TNO dataset, which is around 500 wells, and we were able to download everything all at once and work on it. Because that data is not as nicely formatted as the Cooper-Erlanger dataset that I showed, we sort of chose a bunch of wells, and I've created a video doing that. But no, as far as we can see with uploading and downloading from LogScope, we have no limitations on the amount of information you can upload and download. One of the things I'd say is how fast your connection is and how much time you have. But for example, our Cooper-Erlanger data set, when I uploaded that to the OSDU and did a much more extensive evaluation and pushed that information back to the OSDU, it sort of took around 20-30 minutes to download it and around 20-30 minutes to upload it. And that was on my connection. My recollection is that was to an AWS partition provided by 47 Lining, but I got similar performance from Azure as well, and we uploaded. Like, it's the first thing we wanted to do. Like, how much information can we push up to the OSDU in one hit? So we did over 400 wells, and we thought that's pretty good. So, but it depends how fast your connection is and how much time you're prepared to wait. Like initially I was thinking I might have to do it overnight, but I didn't. It did it in 20 minutes. So I thought this is okay. This is pretty good actually. And so in terms of a data storage system, I'm pretty sold on it, and I like it because I can, if it was within the realms of us using for a service work, I definitely want to use it for that, for delivery of data. But at the moment, nobody's got access to it, so it's we're still delivering data as DLIS files, and if they've got LogScope, we deliver as LogScope archives as well. So that's kind of my thoughts at the moment.
Okay, there's another question. Is it possible to do some processing and analysis on the well log directly on OSDU instead of downloading, processing, and uploading, which is similar to the the other question, but yeah, it's just this one is asking to do it on OSDU directly.
Okay, when we connected to the OSDU, and this is sort of reaching to the limit of my knowledge on how the OSDU works, there were two approaches that we had. One was using last list and dlist files in there, and the other was actually storing the actual curves in the OSDU. And in our development, we found that storing as individual curves in the OSDU, the performance was untenable. It was not really workable. So I kind of think whatever you do, you're going to have to move the information from the OSDU to whatever your target application is, and you're potentially going to have to work on it there, and then push your results back in last list and dlist. Obviously, if they improve the performance of the individual curve and so on, then yes, being able to do stuff directly becomes a valid proposition time-wise. And I hope my software developer is not turning in his sleep and saying, no, don't say anything about that. But I think last list and dlist are perfectly acceptable as formats in the OSDU. We added a LogScope archive as a schema that we could put in the OSDU as well. We did that to help ourselves more than anybody else, and it just meant that we could store everything that we do on a well in the OSDU databases that we were using to sort of trial the workflows that we were building. So that's. I've been reminded that there's one other thing, because our software works on iPad and iPhone. We're able to connect from those platforms as well to the OSDU. So if you're sitting in an airport, you can download our software to your iPhone and you can connect to the OSDU and see what's going on and do stuff there and then push it back. So yeah, so that's that. Hopefully that answers your question there.
All right, thank you. And actually, you already answered the last question as well. Because the last question is, do you have a mobile platform?
Yes, we do. And if you go to the App Store and type in LogScope, away you go. So, yeah.
Okay. Thank you, Nicholas. Any more questions from the audience? Okay. So one more question. The question is, does it connect to WITSML?
Yes, WITSML. Yes, we do connect to WITSML. And that's one of the workflows that we've sort of tried out, is instead of downloading from the OSDU, get your information from the WITSML, do a petrophysical evaluation on the fly, which we can do, and then continuously upload the information back to the OSDU. So as you upload, it just keeps on. Every time you need to upload a new version to the OSDU, you can do that. Yeah, so hopefully that makes sense. Yeah.
Okay, thank you. And let's see if we have more questions. We still have 10, 11 minutes left. Okay, if no more questions, we can conclude this seminar, this moment. And if any of you have questions, please feel free to contact Nicholas directly, so that he can answer your question regarding OSDU, Petrophysics. Thank you, everybody. Thank you. Bye.